Hello, I'm going to show you how to use the R companion package's crosstabC function to generate cross-tabulations that you can use to make comparisons. I'm assuming you've already downloaded RStudio, and have installed the RCPA3 package. If you haven't done that already, you'll want to complete your setup before trying to use functions from the package. I'm also assuming that you have a basic understanding of how to work in the R environment. If you don't know what functions and objects are, you should review Chapter 1 before practicing this skill from Chapter 4. The crosstabC function is one of the most powerful functions in the RCPA3 package, and probably the function we use the most in the book. Now, the required arguments are fairly simple, but there are a lot of optional arguments and plot-related arguments which allow you to do a lot with crosstabC. In this video, I'm going to focus on the function's required arguments and standard optional arguments. I will cover other uses of crosstabC, like making controlled comparisons, graphing relationships, and hypothesis testing, which come up later in the book, in separate videos. The crosstabC function has two required arguments. dv is set equal to the dependent variable, and iv is set equal to the independent variable. The crosstabC function supports a standard set of optional arguments. With crosstabC, you have options to specify observation weights, the dataset name, the number of digits you want to see after decimal points, and whether you want to print the cross-tabulation to an HTML file in your working directory. The compact dvlabs and ivlabs arguments aren't standard options, and you can use them for basic cross-tabulations, so I will show you how to use them in this video. As you can see, the crosstabC function has a lot of other optional arguments, as well as some plot-related arguments, which I will discuss in other videos. To see how to use the crosstabC function to make a basic comparison, let's work through some examples together. I want to show you how to use this crosstabC function to create a cross-tabulation to analyze the relationship between two variables. Just going to load the package as I talk here. We're going to keep in mind when we use this when you use the crosstabC function. So we're going to use this function when we want to study the relationship between two categorical variables. So a categorical, which means nominal or ordinal level dependent variable, as well as a categorical independent variable, and we want to make a cross-tabulation to show the frequency and percentages of cases, as I'll show you in the demonstration. So that's when we use this crosstabC function in that instance, the relationship between two categorical variables. If we want to do something else, univariate statistics or relationship between variables that aren't categorical, we don't use this tool. We would use other tools for that kind of analysis. So now that the package is loaded, let's run an example to show you what I mean. So to use the crosstabC function, I would type its name, crosstabC, and then in parentheses, I would complete at least two required arguments. The two required arguments are dv, to identify the dependent variable, and iv to identify the independent variable. So let's do an example from the NES. Let's kind of pick the first one here, the abortion importance, and for the dependent variable I will pick party ID 3. So what's this going to do? It's going to show me a cross-tabulation between the respondents' self-identified party identification in three categories and how much importance they put on the political issue of abortion. Okay, so we get our our cross-tabulation relationship of the two. So along the columns are the values of the independent variable, Democrat, Independent, Republican, and then the rows give us the different values of the dependent variable, from not at all important to extremely important. Oh, and it gives us a plot. I should mention it gives us a plot by default, a bar chart And the note here tells us that, since we didn't identify which value to plot of the 5 different values, it's just going to pick the first value, the default behavior, not at all important. So we see a plot of the percentage of respondents who say that the issue of abortion is not at all important to them, and that's the response given by 2% of Democrats, 6.12% of independents, and 3.83% of Republicans. The bar chart is corresponding to the percentages across this first row. So that's the basic use of the crosstabC function to generate a cross-tabulation. So I left off with this cross-tabulation and bar chart for the relationship between party identification and the importance of the abortion issue to NES respondents. Now I want to show you some options you might use with crosstabC for this kind of basic usage of the function to create a cross-tabulation. The function does have quite a few optional arguments. If we look at the documentation page, you'll see a list of optional arguments for the crosstabC function. There's quite a few of them, so I'm going to make some separate videos. In this video, just concentrate on the optional arguments you might use for this kind of basic cross-tabulation. Some of them that you might use would be the W argument to identify the sample weights. That's a standard argument and not done differently with crosstabC than other functions in the package. Same with data and digits. The number of digits you want displayed, it defaults to 2, but you can have more or fewer digits than that. But a couple I do want to show you real quick. One is called compact. And by default, compact is false, but you can set compact equal to true if you want an abbreviated table that doesn't show all the information that's reported in the cells by default. So if I say cross-tabulation equals true, compact equals true, it will give me a more compact version of the same table. So in the compact version, the bottom row shows us the count overall, and then the cells for the rows show us the percentages in each cell. So there, for example, like for Democrats, there are a total of 2,854 Democrats reported, and this is the breakdown of their percentages. So 2.8% of the 2,854 Democrats say abortion is not at all important. And if you work out the math, you can find the cell counts, and then you could add up the column percentages to get the overall column percentage, but not strictly necessary to see that. So the compact display can be pretty useful, and maybe is a little more friendly on the eyes. You might have noticed that each time I ran this, it was asking me to hit return to see the plot, and would give me this bar chart. If I don't want to continue to do that, I have the option to set the plot argument equal to false. Now if I run it, I should get the same table, but I just get the cursor back. It's not asking me if I want to see the plot. And so if you're running this function repeatedly and don't want to keep generating the plot or being asked to view the plot, you can simply set plot to false. The other arguments you might use with this crosstabC function for a basic cross-tabulation are the arguments that we call dvlabs and ivlabs. What those do is allow you to supply a vector of names for the values of the independent variable and the dependent variable. So if you notice on the cross-tabulation, by default, we've got the independent variable values labeled 1 Democrat, 2 Independent, 3 Republican, which makes sense, but not the most elegant. To list the numbers here, maybe we want the table to not show, and the table and also the plot to not show those numbers, or have some different formatting for the labels of the party identification. So to do that, I could use the ivlabs argument, and I set the ivlabs argument equal to a vector using the concatenate function, and I'm going to give it three values. So I'm going to say Democrats, Independents, and Republicans. Let's run this and see how it changes the result. So now you can see that the labels for the columns are a little bit more readable than they were before. And we can do the same for the dependent variable values using the dvlabs argument. And I would give it a new vector. And here I might say that it's not at, well, if we know that it's important, it's all judging importance, we might say. And this is not a hard and fast rule. I'm just demonstrating and showing what I might do. Since we know it's a cross-tabulation between party ID and the importance, maybe we don't need to keep saying important, and we could simply say that it's not at all. You know, the importance values are not at all, not to, not to, somewhat, very, and extremely. Okay, so you got to make sure that when there are 1, 2, 3, 4, 5 values, we have 1, 2, 3, 4, 5 items in the vector, so that our new labels correspond to the existing labels. Okay, so now it's maybe even more compact and elegant. You know, we just have Democrats, Independents, and Republicans, and they say that it's not at all, not to, somewhat, very. Well, you can read it. So kind of a nice, simplified, compact table. And the nice thing about the IVLabs and the DVLabs arguments is you can kind of on the fly change the labels that appear in the table or that would appear in the plot without actually changing the levels of the variable itself. So I've changed the displayed labels to improve my cross-tabulation a bit, but I didn't actually change the NES Party ID 3 variable itself. So that's convenient. You could have this same effect by changing the levels of the variable itself, but that it's kind of complicated. You saw that in chapter 3 of the book, how to change the levels and the labels for a variable. But you may not want to do that permanently because that may have some other side effects. So these IVLabs and DVLabs let you overwrite them, the default labels, and control them just at the level of the execution of the function, and not have, which, you know, it's fairly simple to do, and not have unintended consequences from doing that.